Hello and a warm welcome to my presentation. The performance potential of silicon carbide is unquestionable, but what about the reliability aspect, for instance power cycle capability of a SiC power module? Can we expect a silicon-like performance? And if not, what is needed to bring it to this level? With this presentation, bringing reliability to SiC power modules, we will give you the answers to these questions, taking as an example the use case of an electric vehicle charger application. My name is Evangelos Theodossiu, and I am Senior Product Marketing Manager at Vincotech. We will walk through this presentation by starting with the question why reliability in SiC power modules matters, having the focus on the power cycle capability. Once we have understood the issue, we will present you our solution and the results of a power cycle benchmark investigation between Vincotech SiC power modules and competition. We will close the presentation with an overview about Vincotech's SiC power module portfolio for chargers. Silicon carbide power devices had long promised to offer significant efficiency savings compared to the traditional silicon lineup. However, after 3+ decades of research and development efforts, the recent boom in electrical vehicles was the catalyst needed to trigger similar expensive growth in the SiC industry. According to the Yole Market and Technology Report 2021, SiC power modules will reach an impressive 25% share by 2026 of the total power module market, driven by charging infrastructure and electrical vehicles. Looking on some charger trends on the right hand, let's focus on two of them, efficiency and reliability. To meet the target total system efficiency of up to 98% and even higher, and to enable high power density and reduce system costs, silicon carbide device with their outstanding electrical performance will be the right choice. On the other hand, one important acceptance criterion is also the reliability of the SiC device under the operation conditions for charger, for instance. Thus, no differentiation will be accepted between a traditional silicon-based power module and one based on silicon technology. However, despite the similarities to silicon, there are important differences related to the material properties itself between silicon and silicon carbide, which have impact on the reliability. In this presentation, we will mainly focus on the reliability in terms of power cycle capability and rather, for instance, gate oxide reliability or short circuit ruggedness or silicon carbide body die degradation. To evaluate the power cycle capability of silicon carbide device and to make some lifetime predictions of the silicon carbide power module in the real application for instance charger, the aging of the interconnection technologies has to be taken into account. Contrary to the superior electrical properties compared with the silicon, the mechanical properties of silicon carbide predict different power cycle capability. Because silicon carbide has a higher Young modulus than silicon, 3 times higher, the silicon carbide chips in power modules induce a higher amount of stress, specifically plastic strain, into the solder joint during a temperature cycle. Therefore, the aging mechanism for soldered silicon carbide chips in modules is not so much the degradation of the bond connection, but dominated by the degradation of the solder layer. On top, additional stress will apply on the solder joint because the chips, especially silicon carbide devices, are getting smaller, the mission profiles are getting harder, for instance for charge applications with long period of maximal power, and also the thermal management is getting harder with high chip temperatures together with high current. Taking all this into account, the reinforcement of the chip solder joint is crucial to improve the power cycle capability. Our engineers took care about this and implemented successfully a new advanced solder alloy, bringing reliability of silicon carbide power modules back to the track. It is well known that the power cycle capability can be assessed via power cycle tests, where the device is actively heated to induce a high delta T to alter the solder joint until a predefined change of RTH junction to case is reached. For comparison reasons with the competition, a flow pack E1 silicon carbide power module was chosen as test vehicle. The housing is an industry-easy 1B package housing, including a 6-spectacle topology with silicon carbide MOSFET chip technology inside. The test parameters have been set to keep a constant T-junction max of 150 degree and 175 degree. The induced delta T was 100 Kelvin respectively, and the T on time 1 sec. The failure criterion was a 20% increase of the RTH for each single chip. On the bottom left graph, the monitoring of the RTH curves over time can be seen. The red dashed curve indicates the 20% RTH increase and marks the failure time of each single chip. The analysis of the failures has been done with a Weibull probability distribution function seen on the bottom right graph. The parameter that we will use for the benchmark purpose will be the so-called characteristic life, which represents the typical time to failure. On the left-hand graph, we are comparing the power cycle characteristic life between silicon and silicon carbide power modules from Vincotech and competition, with a standard solder at T-junction max 150 degree and 175 degree. As expected, the higher stress of the solder joints reduces significantly the power cycle capability by a factor 7 on silicon carbide devices compared to silicon devices at T-junction max 150 degree. We have not observed any noticeable difference between Vincotech and competitor silicon carbide power module. That means in both cases the interconnection technology is similar. Obviously, the lifetime at T-junction max 175 degree is even lower. To understand better the impact of the reduced power cycle capability of the lifetime of a silicon carbide power module, we have to look on the power cycle curves, which can be generated based on a lifetime model and the measured Weibull parameters, to be seen on the right hand side. Taking into account assumed charger mission profile like it is described here, we can calculate a lifetime of, in case of a silicon power module, of 16 years, which will meet the current requirements. On the other hand, for the same power module with silicon carbide devices, the expected lifetime will be reduced down to 2.2 years, which is far away from the minimum 10 years lifetime specification for a charge application. Let's have a look now on the results after the introduction of our new solder alloy. As we can see on the left side hand graph, the silicon carbide power cycle capability was pushed close to a level of cycle capability just like silicon with a standard alloy. Even at T-junction max 175 degree, Vincotech silicon carbide power modules outstanding the competition at T-junction max 150 degree. Assuming the same charge emission profile as we did before, the lifetime of a silicon carbide power module with a new solder is now increased up to 15 years and meets again the current requirements in terms of power cycle capability. Of course, in case a more realistic charge emission profile is available, a lifetime prediction can be done based on the lifetime curves which are available upon request. And before I'm going to close now the presentation with a summary, let me give you a short overview about the silicon carbide power module portfolio. Currently, we are offering more than 40 different part numbers using SiC technology based on a multi-source chipset supply chain and of course the new interconnection technology which was presented in the previous slides. They are standard industry housing and custom housings that can fit perfectly to each application. We have a dedicated product line for DC fast charge applications with a comprehensive portfolio for each conversion state for the AC-DC and for the DC-DC, including state-of-the-art topologies and giving the best trade-off between efficiency and costs. For more detailed information, please visit our dedicated landing page for chargers to be found at our webpage vincotech.com. And I would like to close my presentation with some takeaways. Vincotech's advanced new interconnection technology is an efficient and especially cost-effective solution to solve the reliability challenges of silicon carbide power modules regarding power cycle capability. As a technological outlook, our engineering team is continuing the investigation on new solder alloys to fully utilize the technical limits of this interconnection technology, but also looking on new technologies like Cinder to meet future requirements. Vincotech has strong roadmap of silicon carbide power module technologies addressed for different market segments, but covering the electric vehicle charger segment with distinction and meeting the specification for high reliability. With this, I'm closing the presentation. I would like to thank you for your attention, and I'm looking forward to get in touch with you and assist you together with our team bringing reliability to your silicon carbide power modules.